Hello, this video is for IXL A1.C.5 titled Solve Proportions. The 3-character code for this activity is 2 Zulu Lima. So solving proportions. In a proportion, remember a proportion is two ratios set equal to one another. That is, say, two fractions, such as D is to 4 as 15 is to 10. So we have to find out the value of D here. And we're going to do this by multiplying our extremes and setting that equal to the product of our means. And you might be, what do you mean extremes and what do you mean means? So in this case, let's take D is to 4, right? This is a ratio. We could write this as D is to 4 using a colon, D is to 4, as 15 is to 10, whereas 15 is to 10. And you'll see that the 4 and the 15 are closer to the middle here. So we're going to call this the means, M-E-A-N-S. The means kind of like the middle, the average, right? So these are our means, 4 and 15. Those are the means. And more out towards the outside, further out from the middle here of the equal sign, these are going to be our extremes. Extremes. There, see if I can spell today. And because they're like further to the outside. Someone's like, wow, he's really way out there. They say, oh, he's extreme. So that's the idea. The ones in the middle, whenever we set up a proportion like this, where we write the ratios using colons, the values that are closer to the middle are the means, and the ones on the outside are the extremes. And you'll see that in this case, my extremes are here and here, the upper left, lower right. And we'll change colors here. And my means are the lower left and the upper right. So we're going to do red times red and green times green. All right, I'm going to erase all this in just a minute. But before I did, I just want to explain that. So as I say, I'm going to multiply my extremes and set that equal to the product of my means. Or I'm going to take the product of the extremes and set that equal to the product of the means. That's exactly what I'm doing. Many people just call this simply cross products. They're doing cross products for that. So whether you call it cross products or multiplying your extremes and setting that equal to the product of your means, etc., that's kind of like the way I like to do it, right? That good old academic vocabulary. So multiply my extremes. D times 10. Well, I'm just going to write that as, and I do prefer red over green, so I'm going to go back to my red. So 10 times D is just 10 times D, 10D, right? And 4 times 15, well, that should be what, 30, 60, correct? So now I just have a one-step equation here. I need to solve for D. If we were doing one-step equations, you say, oh, the D's tied to the 10 by multiplication. The opposite operation is division, because every fraction is a division problem. I'm going to divide by the very number I wish to get rid of, which is 10. And what I do to one side, I'm going to do to the other. Well, the 10s would cancel each other. Leave me with just D, and 60 divided by 10 is 6. So the value of D is 6. This means that 6 over 4 is equal to 15 over 10. So we're just going to do some cross products. We're just going to end up with a one-step equation in which we can then divide by some number that's tied to the variable. And later on, we might get into some problems that involve some distributive property and that type of stuff, but we'll be okay. So let's go ahead and move along here. And this one here, multiply the product of our extremes, 15 times 8. I'm going to write this out for a couple times. 15 times 8, and we're going to set that equal to 12 times b. Now let's do 15 times 8. Well, 8 times 10 is 80, and 8 times 5 is 40, and 80 and 40 is 120, is it? And set that equal to 12b. Now divide both sides by 12, and 12s cancel each other. They may be on the right, and 120 divided by 12 is indeed 10, so b equals 10. On the next one here, multiply our extremes. That's going to be 15 times 10, and I'm going to set that equal to 3 times k, which is 3k, and 15 times 10 is 150. Set that equal to 3 times k, and now we're going to solve for k. So k is tied to 3 through multiplication. Let's divide by the very number we wish to get rid of. What we do to one side, we're going to do to the other. And we're going to be left with just k on the right. And 150 divided by 3 should be 50, correct? So k equals 50. The next one here, wow, some big numbers here. So we're going to do 186 times 304. And that's our extremes. Now we're going to multiply that times 228 times V. Now let's go ahead and do, and I am not going to mental math 186 times 304. So 186 times 304 is going to give me 56,544. 544. And bring down that 228V. Now let's go ahead and divide both sides by 228. So I've already got that 56,544 in my calculator there. So now I'm going to go ahead and divide that by 228. So divide by 228. And that's going to give me an answer of 248. All right, so 248 is my correct answer. All right, let's move along to the next one. This one shouldn't be nearly as bad, not nearly as big a number. So 3 times m, multiply my extremes. 3m, set that equal to 10 times 24 is 240. Now divide both sides by 3 and I end up with m and 240. We'll go ahead and write that divided by 3 there. They cancel. So 24 divided by 3 is, what is that, 8? So throw that 0 on there. So m is going to equal 80. Oh, goody goody. Decimals. Well, this isn't too bad. 17.6 times 1 is still 17.6. Anything times 1 equals itself. So the extremes were pretty easy. And then we have 4.4 times p, which is 4.4p. Now let's divide both sides by 4.4. We do to one side, we're going to do to the other. 4.4 is going to cancel each other, leaving me with just p on the right. And then 17.6. I'm going to divide that by 4.4, and that's going to give me an answer of 4. So p equals 4. Here we have 18, and I'm going to go ahead and write this out. I'm multiplying 18 times 13.6. That is my extreme. Look for the product of my extremes. Set that equal to the product of my means, which is 16 times p, or that is to say 16p. So let's do 18 times 13.6. As abstract as I think 16p, that's not a very big resolution on a television screen. And the product of 18 and 13.6 is 244.8. Let's bring down that 16p. Now let's divide both sides by 16. It's going to leave me just p on the right. And 244.8, I already got it in my calculator. Divide that by 16, and that's going to be 15.3 is my solution. 15.3. All right, now we get a little tricky. Now we're getting like these expressions for a numerator or a denominator. There's a couple ways we could approach this, and we'll look at both of those, okay? So we could first do the product of our means. So let's do 12 times 15, and then set that equal to the product of our extremes, 12 and 15. Now we're going to set that equal to the product of our means. So this is 9 times the quantity of c plus 5. Now, I could go ahead and multiply the 12 times 15, and we'll go ahead and do that. 12 by 15, and that's going to give me 180. Ooh, I see something, a shortcut. Now, some people might say, okay, you need to distribute this 9c, and it's going to be a longer way around, but let's look at the long way to do it, and then we'll look at the short way to do it. So 9 times c is going to be 9c, and 9 times 5 is going to be 45. So that's the distribution property there. Now I need to get the 9c by itself, because I have a two-step equation here now. So 180, and I'm going to subtract 45 from each side. That's going to cancel. Subtracting 45 is going to get rid of the positive 45 there. And 180 minus 45 is 135. And bring down the 9c. Now let's divide both sides by 9. 135 divided by 9 equals 15. So here I got an answer of 15. Now there is probably a shorter way to do it. Let's look at that. Let's look at a shorter way to do it. I'm going to go back to this step right here. And I could have left the 180 right here. Let's do 180 here. All right. Equals 9. And let's bring the c plus 5 down. Now I could just divide both sides by 9 like this. Plus, since 180 has a nice little relationship with 9 there, the 9s would cancel each other, leaving me with just c plus 5 over here. And then 180 divided by 9, well, 18 divided by 9 is 2, right? Throw the 0 on there. Now I just need to subtract 5 from each side, and I would still end up with C equals 15. There's another way that I was thinking about doing this. If we just think about this as, well, whenever I do it on the calculator, I was doing this earlier, and I just kind of think of this whole thing as C as being like X, right? X equals C plus 5. So I kind of think of it that way. So I end up doing the 180 product of 15 and 12 and 9x, right? And then divide both sides by 9, and I end up with 20, right? Well, 20 is x, and then I go back and think, okay, whatever x is, right? Then on the calculator, I would kind of go back and substitute that C plus 5, right? And then subtract 5 from each side to end up with 15. So however you want to do it, several processes there. So let's go ahead and look at the next problem. 3 times 32 is our extremes, 3 by 32. We're going to set that equal to 24, 24 times the quantity of C plus 3. So let's go ahead and 3 times 32, was it 96, is it? 32 by 3? Yep, 96. 96 equals 24 times C plus 3. I'm going to guess, is 96 divisible by 24 divided by 24? I think it is. It would be 4. Yep. So I'm going to divide both sides by 24. Write that out so you can see what I'm doing there. 24. Now the 24s cancel each other, leaving me with just the C plus 3 here. And this is definitely a review on algebra. If you don't know about solving one-step, two-step equations, you might want to go back and revisit that. But 96 divided by 24 gave us an answer of 4. Now let's subtract 3 from each side. Minus 3, minus 3. You know, 1 on the left and C over here, so C equals 1. You could have distributed that 24 in. Personally, I think it's the longer way around of doing it. Here's a couple more here. 40 times 10. Well, 40 times 10 is what? 4 times 1 is 4 and a couple zeros, so that's 400. Equals 8 times the quantity of B plus 18. Now, I think 400 is going to divide by 8. It definitely should. Yeah, I know it will. So 400, we're going to divide it by 8, and that's going to be 50. And silly me, I really didn't need a calculator for that. But what I do is I divide it by 8. Let me erase this here. I know I'm getting it. Sometimes I just make assumptions everybody understands. So I divide it by 8, and I get rid of the 8s there. And that's going to leave me with the B plus 18. And 400 divided by 8 is 50. And now I need to subtract 18 from each side. Subtract minus 18, minus 18. That's going to cancel those 18s out, leaving it just B on the right. And 50 minus 18, well, 50 minus 20 is 30. Throw 2 more back on there. Should be 32, right? You can always double check. 32, 42, plus 8 more. Yep, 50. So B equals 32. And final example, 26 by 16. 26 times 16. And no, I'm not going to mental math that one. 13 times A plus 12. So let's go ahead and do the 27. I'm seeing that 13 is related to the 26 because 26 is twice as much as 13. And I'm thinking about factoring something out there, but no, I won't do it. We'll go ahead and stick with the same process, but we could do some factoring. I see a relationship between 13 and 26 I'm kind of wanting to take advantage of, but I'll come back and do that in a little bit so you can kind of see what I was talking about. So let's just take the normal route. 26 by 16. So the product of our extremes is 416. 416. We're going to set that equal to 13, bring down that A plus 12. Now, I'm going to guess it. 416 will divide by 13. I'm pretty sure it will divide by 13. And indeed it does. It equals 32. So I divided both sides by 13. And I get a result of 32 on the left. And the 13 is going to cancel each other, leaving me with the A plus 12. Now I just need to go ahead and subtract 12 from each side. Well, that's easy enough. That's going to give me 20 over here, right? And A. So A equals 20. So if you're wondering what I was thinking about up here, a little shortcut that I was thinking about taking was, I was thinking about taking this 26 right? And think of this 26 as 2 times 13, right? I'm like, okay, and I would have done this mentally. And I would have thought, okay, divide by 13s, right? If I divide by 13 on each side, then 13s will cancel each other. And that leaves me with a 2. 2 times 16 is 32 equals, and those 13s would have canceled. That'd be a plus 12. And then I would have just gone ahead and subtracted 12 from each side to get 20 there. So I kind of spotted that special relationship between the 26 and the 13 that we originally had there. And that would have been another way to approach it as well. Just depends upon when you want to factor things out. If you want to use the distributive property of distributing 13 into the quantity of a plus 12 and end up with a two-step equation in the end, you could do that. I just think it's easier to leave the expression a plus 12 alone, especially whenever they're dividing out nice and evenly and they're not ending up with decimal values there. Just my opinion on that one. All right, so that concludes all of my examples for IXL A1.C.5 Solve proportions, and good luck with the activity.